A massive beam of energy, origin unknown, stretching across space and somehow connected to the interstellar visitor 3I Atlas, has scientists scrambling for explanations and raising profound questions about our planet's protective magnetic shield. What we're witnessing right now might be one of the most significant astronomical discoveries of the decade, and yet it's flying under the radar of mainstream news coverage. Let me take you back to when this story actually begins. 3I Atlas, for those just hearing about this, isn't your typical space rock passing through our solar system. This is an interstellar object, meaning it originated from somewhere beyond our sun's gravitational influence. It came from the depths of space between the stars, traveled for who knows how many thousands or millions of years, and entered our cosmic neighborhood in late 2024. Now, interstellar visitors aren't completely unprecedented. We've had Oumuamua back in 2017, which caused quite a stir with its unusual cigar shape and acceleration that couldn't be fully explained by normal outgassing. Then we had Borisov in 2019, which behaved more like a typical comet. But 3I Atlas is different, and the beam phenomenon associated with it is unlike anything we've encountered before. The detection of this beam happened almost by accident. Researchers monitoring Earth's magnetosphere using a network of ground-based magnetometers and satellite instruments noticed unusual fluctuations that didn't match any known pattern. The magnetosphere, for context, is Earth's magnetic field extending tens of thousands of kilometers into space. It's our invisible shield against the solar wind and cosmic radiation, protecting our atmosphere and making life on Earth possible. Scientists study it constantly because understanding its behavior is crucial for everything from satellite operations to predicting auroras to protecting astronauts. What caught their attention was a directional disturbance, a perturbation in the magnetic field lines that seemed to be coming from a specific point in space. When they traced back the geometry of these disturbances, the source aligned almost perfectly with the trajectory of 3I Atlas. But here's where it gets really strange. The object itself is relatively small for an interstellar visitor, estimated at only about 200 to 300 meters across. It shouldn't have enough mass or electromagnetic properties to influence Earth's magnetosphere from millions of kilometers away. And yet, the correlation between its position and these magnetic anomalies is too precise to be coincidental. Several independent observation teams have now confirmed the beam's existence using different methodologies. Some detected it through its interaction with Earth's magnetic field. Others identified unusual particle streams using space-based instruments. Radio astronomers picked up faint but distinct emissions along what appears to be a narrow corridor connecting 3I Atlas to Earth's magnetosphere. The beam isn't visible to the naked eye, and it's not a laser or anything like science fiction might suggest. Instead, it appears to be a focused stream of charged particles and electromagnetic radiation following a path that defies our current understanding of how such phenomena should behave in interplanetary space. What makes this even more perplexing is the beam's characteristics. It's narrow, perhaps only a few hundred kilometers wide across millions of kilometers of distance, which suggests an incredible degree of collimation or focusing. Natural processes in space tend to be diffuse and spread out. Solar wind, for instance, radiates in all directions from the sun. Cosmic rays scatter as they travel through magnetic fields. But this beam maintains its coherence across vast distances, almost as if something is guiding or focusing it. The energy levels involved aren't catastrophic, thankfully, but they're significant enough to cause measurable effects on Earth's upper atmosphere and magnetic field. Scientists have proposed several theories, each with its own problems and implications. The first hypothesis is that 3I Atlas might have an unusually strong magnetic field for an object its size. Perhaps it contains materials or structures that generate magnetism in ways we haven't encountered before. Maybe it's rich in metallic iron or has some exotic crystalline structure that creates powerful magnetic effects. If this object came from another star system, It could have formed under very different conditions than objects in our solar system, potentially leading to unusual properties. But even if it has a strong magnetic field, that doesn't fully explain how it's generating a focused beam toward Earth specifically. The second theory involves the solar wind as a mediator. As 3I Atlas moves through the stream of charged particles flowing from our Sun, it might be creating a bow shock or wake, similar to how a boat creates waves as it moves through water. Perhaps this interaction with the solar wind is somehow channeling energy toward Earth through complex electromagnetic processes. Some models suggest that if the object has the right combination of velocity, composition, and magnetic properties, it could set up a kind of plasma conduit. But again, the precision and stability of the beam don't quite fit what we'd expect from such chaotic interactions. A third possibility that's being quietly discussed in academic circles is even more intriguing and controversial. What if 3I Atlas isn't entirely natural? Now, before anyone jumps to conclusions about alien spacecraft, let me be clear that there's no evidence of artificial origin. But the question being asked is whether this could be a natural object that's been altered or is carrying something artificial. Some researchers have pointed out that an advanced civilization might use interstellar objects as carriers for probes or instruments, letting them hitch a ride on naturally occurring comets or asteroids to travel between star systems. It's actually a concept that human scientists have proposed for our own future exploration efforts. If there were some kind of active technology on or within 3I Atlas, it might explain the beam's unusual properties. The implications for Earth's magnetosphere are what have some scientists genuinely concerned. Our magnetic field isn't static, it fluctuates naturally, and it's been weakening gradually over the past few centuries. We also know that the magnetic poles wander and have even flipped completely many times in Earth's geological history. What we don't fully understand is what triggers these changes or what might accelerate them. Could external influences like this beam affect the magnetosphere's stability? Probably not significantly from what we're seeing now, but the very fact that an external object can create detectable effects raises questions about other potential influences we haven't considered. The beam's interaction with our magnetosphere has produced some observable effects. There have been reports of unusual aurora activity at latitudes where they're rarely seen. Some satellite operators have noted minor anomalies in instruments that monitor space weather. Radio communication in certain bands has experienced brief periods of interference that correlate with the beam's strongest measured intensities. None of this is causing major problems, but it's enough to confirm that something real and measurable is happening. What's particularly fascinating from a scientific perspective is that this gives us an unprecedented opportunity to study our magnetosphere under novel conditions. It's like having a natural experiment delivered to us from interstellar space. Research teams are now coordinating observations using every available instrument, from ground-based magnetometers and radar systems to satellites and space telescopes. They're gathering data on particle densities, magnetic field variations, radio emissions, and anything else that might help explain what's happening. 3I Atlas itself is expected to reach its closest approach to Earth in the coming weeks, before continuing on its journey out of the solar system and back into interstellar space. Scientists are racing against time to gather as much data as possible while this opportunity lasts. Multiple space agencies are reportedly considering whether it's possible to redirect any existing spacecraft for a closer look, though the logistics and timing make this extremely challenging. The broader implications of this discovery extend beyond just this one event. If interstellar objects can influence planetary magnetospheres, what does this mean for our understanding of how planetary magnetic fields evolve over time? Could such interactions have played a role in Earth's magnetic history? What about other planets in our solar system or exoplanets orbiting distant stars? These are questions that researchers are now beginning to explore. There's also the sobering realization that we have limited ability to detect or track all interstellar objects passing through our solar system. 3I Atlas was discovered relatively late, and we had even less warning than we did for previous interstellar visitors. If such objects can have measurable effects on Earth, even minor ones, it highlights the importance of improving our detection and monitoring capabilities for these cosmic travelers. As this situation continues to develop, the scientific community is calling for more resources, more observation time on major telescopes, and better coordination between different research groups and space agencies. What we're witnessing is science in action, the process of discovery unfolding in real time. We have observations that need explaining, theories being tested and revised, and more questions emerging with each new piece of data.